Hi, I'll be proving in this video the following result. So, if I consider Z a center normal distribution, I want to prove that the variance of Z is equal to 1. So let me remind you what is the variance of Z. We can write it as the expectation of Z square minus the expectation of Z square. And this random variable has a density function equal 1 minus over square root p exponential minus z squared 2 over 2. Okay, so what if we want to compute variance z? So we need to compute expectation of z squared and we need to compute expectation of z. Then, indeed, first, so expectation of z is equal to 0. Why? Because the expectation of z is equal to the integral of z fz dz. It is then equal 1 square root 2 pi, the integral from minus infinity to z exponential minus z squared 2 dz. So z exponential minus z squared 2 over z is a knot function, and we are computing in an integral with center 0, in an interval of center 0, then this one is 0. Okay, let's now compute the expectation of z square. To do that, we need to recall the following function, what we call the gamma function. It is a function defined in this way. So t power z minus 1 exponential minus t dt. And for the computation of exponential z square, I need to recall that gamma third half is square root pi over 2. Okay, so let's go. So let's clean then this blackboard and go ahead. So let's write down the expectation of z square. So it's the integral z square fz dz. It's then 1 square root 2 pi z square exponential minus z square minus z square dz, and I will be computing this from minus infinity to plus infinity. Okay, this function actually is now an even function, and then its integral should be equal, so it's to be twice the integral from 0 to infinity of z square exponential minus z square over 2 dz. Okay, let's consider the following change of variable. So first of all, if z or t positive, if as only if t is positive. Second, this change of variable is equivalent to write that z is equal square root 2 t is equal to dz dt over square root 2t. Okay, let's go back then to the expectation of z square. So it's 1 over 2p, 2 pi. So now we write everything with t. Then here will be do t, since z square is equal to 2t exponential minus t dt over square root 2t. Okay, so let's go. So here, square root by square root, it takes me 2, and 2 will be simplified. So then we have 1, 2 only. Here we have 2 power 1 over 2 power half. Then we have 2 power 1 half. So I can write it 0 to infinity t power 3.5 minus 1 exponential minus t dt. And I shouldn't forget here I have square root pi. Well, look, here is exactly gamma 3.5, and then this is 2 over square root p by square root p over 2 is equal to 1. Okay, this all. Then that's all. Though, if I want to conclude, so variance z is equal, we said that expectation of z square minus expectation of z square, this is equal to minus 0 equal to 1. Okay, thank you.